Hello everyone, and welcome to our 22-minute webinar today, Predict Product Performance Earlier. My name is Amy Green, and I will be your host. Thank you for joining us today. A couple of notes before we begin. Just wanted to give you an introduction into the interface today. For the remainder of the webinar, you will be placed on mute to avoid background noise and interference. If you have questions throughout the webinar, please enter them in the text-based chat window on the left-hand side of your screen. This panel can be hidden using the button on the upper left corner or by entering into the full screen mode using the full screen button on the upper right. Throughout the webinar, we will be asking poll questions to keep this presentation interactive. Please select from multiple choice answers in the middle of your screen as quickly as possible. We will be responding to questions during the webinar using the chat window, as well as have an in-depth Q&A session with our expert today at the end of the demo portion of the webinar, so stick around to get your questions answered live. Now I would like to introduce today's presenter, Delphine Genovrier. Delphine has been in the simulation arena for many years. She originally started with SRAC, Structural Research and Analytic Corporation, in 2000 as an application engineer. SRAC was acquired by Dassault Systèmes in 2001 and is the FEA solution we now use in SolidWorks Simulation. Delphine has had many roles focusing on simulation while here at SolidWorks, from business development manager to product manager, where she works today as product manager for the entire SolidWorks Simulation suite. She's excited to be here today to show you the exciting new features in SolidWorks Simulation 2014 that can help you predict your performance earlier and be more innovative in your designs. Welcome, Delphine, and thank you for joining us today.
Thank you, Amy, and hello to everyone, and welcome to this web session. So today's presentation is all about performing efficient product performance testing earlier in your product development process. So in 22 minutes, our objective is to present you SolidWorks Simulation and how this 3D engineering tool can help you to better assess how your final product will behave in real life. There is an idea that simulation, or FEA, is only for FEA specialists and mainly used in aerospace or automotive industries. Moreover, simulation is often valued as a tool used at the end of the product development cycle for final validation only. This time is over. The world of design, the world of engineering has drastically changed, and we have entered in an era of simulation-driven engineering. So today we'll cover SolidWorks simulation applications with demonstration, as well as a key new feature of the 2014 release, which helps product engineers to become even more efficient in product testing with SolidWorks simulation. So we have a lot to cover today in 22 minutes, so let's get started. Of course, it is a given that product engineers have to make sure that product needs to meet its technical requirements. That's part of the job. But often, this is understood as requirement based on a geometrical criteria such as mass, volume, size, or on material criteria. The mechanical resistance of the product is often resolved with over-dimensioning. But over-dimensioning leads to profit loss and products which are not optimized to reach or keep new markets. And this is really what virtual product performance testing is all about. Often, virtual testing is seen as a tool to avoid failure, but this is not the only application. Indeed, the goal of performance testing is not only to find issues, but it is really to eliminate performance bottlenecks. Performance testing uncovers what needs to be improved, what needs to be optimized before the product goes to market. Indeed, products tend to market with poor performance metrics due to non-existing or due to poor performance testing are likely to gain a bad reputation and fail to meet expecting company goals. Also, mission-critical applications such as medical equipment should be performance tested to ensure that they will run for a long period of time without any deviation. So what do we get with if you are doing virtual performance testing? At first, testing the performance of a product during the product development process offers answers to your technical doubt, to your technical questions beyond pure geometry criteria. You can test, for example, if your product supports the operating workloads in different environments or use cases. You can test if your product lifetime is the expected one for maintenance planning, for example. And you can test if your product won't deform too much in extreme temperature environment and much more. But really the goal is to get these understanding as early as possible so you have enough time, you have the possibility to make design adjustments, design changes to improve the product performance. So you can then become proactive and then avoid late issue discovery at the manufacturing or during the real prototyping steps, when often it is too late to make any significant design changes. Finally, testing product performance provides you a better knowledge of your product behavior and enables you to boost your design creativity, design innovation, and finally increase customer satisfaction. So the question is, when should you test the product performance for maximum impact in your company? Often in traditional product development process, the testing phase is done after the design phase, in traditional simulation tools or during physical prototyping, or in some cases it can be outsourced to external companies. But to get the full benefit of virtual product performance testing, do not wait too long before checking your design. Really, the objective is to integrate simulation during the design phase with what we call a concurrent engineering approach. Indeed, to be able to understand as early as possible how your product will perform under workloads, and if needed to be able to make design changes, you need to get those technical insights as early as possible. So simulation with that concurrent engineering approach become a 3D design tool for all product engineers and not anymore a validation tool for specialists only. So let's see now how SolidWorks can help you to test product performance efficiently. And the answer is a solution called SolidWorks Simulation. So let's discover that solution today.
Thanks, Delphine. We have our first polling question now, so please go ahead and answer in the middle of your screen using the multiple choice answers. In your company, are you using physical prototyping for performance testing? Yes, of course we use it for all of our products. Yes, but only for certain products that we find critical. No, we don't do performance testing, physical prototyping at this moment. So we'll give people a few minutes to respond, and it looks like the majority so far are only using for their critical products. Is that what you're seeing generally in the field in your experience, Delphine?
Yes, unfortunately, this is exactly what we see on the field. For people who are doing physical prototyping, either internally, either with external labs, usually this is done only for critical products to avoid, failure on those critical products. The problem with that approach, of course, you will get, valuable insight for those critical products, but it can be too late. Maybe they're already manufactured. But the worst is that you are testing only critical product. This approach is not helping you to optimize your entire product line, for example, to attack a new market or to stay a leader in a market. So that's why, we are proposing to do virtual simulation. The goal is not to replace physical prototyping, but in average, our customers are reducing by 50% their physical prototyping by using virtual prototyping, which is significant in time or in cost issues.
That certainly is. Thanks, Delphine.
No problem. So let's discover the SolidWorks simulation solution. Of course, virtual simulation, it can be FEA or CFD, exists in decades, but the unique value of the SolidWorks simulation solution is its philosophy towards, again, concurrent engineering and the usage of simulation by product engineers. So what does this mean? This means that it has been developed with this in mind, so every engineer in any industry can benefit from a robust but intuitive engineering tool. All the simulation tools in our solution are fully embedded, fully integrated within the SolidWorks CAD environment. So all CAD users can benefit from simulation at any stage of product development. The analysis capabilities are fully integrated, sharing familiar workflow with SolidWorks CAD, naming convention and commands, shortening then, of course, the learning curve. But the single Windows integration of SolidWorks Simulation solution has benefits beyond its ease of use. As you modify geometry and parameters information during design changes, the simulation studies update automatically. So you can validate your initial design, then change your design and understand how each design element affects performance. So designers then benefit from ease of use, 3D tools with very powerful simulation capability to cover your design issues. Something very important as well is that the SolidWorks simulation solution is complete and consistent. It offers structural analysis with the product called SolidWorks Simulation, fluid flow and thermal analysis with CFD with SolidWorks Flow Simulation, dynamic motion simulation with SolidWorks Motion, injection plastic simulation with SolidWorks Plastics, and environmental impact simulation with SolidWorks Sustainability. So this is the solution. And all these tools, again, are fully embedded within SolidWorks and can be combined together for an in-depth performance testing combining different physics. So with this complete and very current portfolio, you can get valuable knowledge with very little process overhead. So this is the solution, but let me zoom in on the product called SolidWorks Simulation. So SolidWorks Simulation is one tool of the SolidWorks Simulation solution, and this is a structural analysis tool. It can be called as well FEA, Finite Element Analysis. Again, fully integrated inside SolidWorks 3D CAD. SolidWorks Simulation allows the CAD user to ensure product quality and performance way before manufacturing. So designers with SolidWorks Simulation can carry out a wide range of analysis to assess the product performance during the design phase. As it is embedded inside SolidWorks, you can leverage the SolidWorks configuration and the CAD integration to evaluate design alternatives and obtain a robust design. And we were speaking about prototyping, and our users minimize real prototyping costs by getting their product right first time. Of course, SolidWorks Simulation helps as well our users to optimize their design for cost, quality, and performance. So they can do that through weight optimization or also by evaluating alternative materials. So you can as well predict product and component lifespan and maximize then product quality. The goal in general of SolidWorks Simulation is to predict product performance earlier so you can find design alternatives for an optimized product.
So now we have our second polling question. In your company, are you using virtual simulation, or FEA? No, not in in-house solutions. Yes, we use SolidWorks Simulation. Or yes, we use another FEA solution. So give people another few seconds to respond. But it does look like most people do not use in-house solutions. But we also have another 40% that do use SolidWorks Simulation. So glad that you guys are here with us today. We will get to a demo portion pretty quickly in the next couple of slides. So we'll get more information on that as well.
Yeah, thank you, Amy. So what I will start with demonstrating some of the key capability of SolidWorks Simulation, and then we'll cover the key new feature in 2014. So for the people who already know SolidWorks Simulation, you will learn the new feature, and you might learn as well new other applications that you might not be familiar with. So for the, let's say, the discovery tool of SolidWorks Simulation, I would like to start with a stress analysis and a fatigue analysis. So the objective is to test if a product will support a workload as well as the durability of that product. So answering such question is true for nearly all product manufacturers. At first, will it support the load? And then will it offer the life expectancy requested? So let me show you a video to illustrate fatigue and static analysis. Okay, so this presentation focuses on investigating the performance of components using a bicycle crank as an example, what you can see on the screen now. Of course, when designing products, as I mentioned, knowing if it will work is critical, or however, knowing how long it will last is just as important. And the strength of most material reduces under repeated loading. This means that over a period of time, even a load well below the yield strength will cause a part failure. This behavior is commonly called as fatigue. So what if you could test the life of a part in a matter of seconds to make sure we'll have the best design choice? And this is, what I would like to show you in this demonstration. So SolidWorks Simulation gives you that ability. And by incorporating the material strength variation with repeating loading, SolidWorks Simulation can provide excellent insight into the life of a part. So here in that example, as you can see, we have 3 configurations. We have 3 different crank designs, but we want to know which one will last the longest. They are all made out of 61 forged aluminum. So at first, we'll define our static analysis. We define the material using the material library of SolidWorks Simulation that you can free customize. You define then the features and the load. And something great is that you will define them on the geometry. So if the geometry changes, automatically your condition will be updated. You don't need to think about that. For the loading in that example, we are going to assume the full weight of a rider is applied through the pedal to the crank. And to represent an extreme case, we will use a load of around 1,000 newtons. So again, just need to select the faces and apply the load. Once it is done, our simulation setup is complete, so we just need to run the simulation and get the static results, which are the stress distribution, displacement distribution, so basically to understand if the part will support the workload. So what you can see here is that the stress level is way below the yield strength. You can see here the animations to understand how your components will get deformed under the workload. You can very easily isolate where are the maximum value of the result, for example here the stress level, and with the ISO surface to really understand where the critical area might be in your design. But really to test if the product will support the workload, we can have a look on another result, which is called the factor of safety. So the factor of safety is to test if the stress level is more important or less important at the yield point. So this is what we'll do here. And what we can see is that we do not have any problem. Our factor of safety is way more important than 1. So here, that component will support the workload. You can exchange that result in e-drawing, for example, if you are already familiar with e-drawing. Now let's answer to our second question. Will it support the what about the durability, of that material, of that part? So the goal here for the crank is to last around 25,000 miles of riding, or about 7 million load cycles. So we define those 7 million cycles, and we test the durability with the fatigue analysis. So we've done that with the first configuration. Remember, we have 3 configurations, 3 alternatives to make the best choice. What we just need to do, we simply copy and paste the static analysis on the first configuration and rerun the analysis. So here, again, all the features, the material, the load are automatically updated, so you don't need to really find them in SolidWorks Simulation. So you can do 10, 20 configuration, and simply by copying and pasting the study, you can test all the design alternatives. So then you can see that the maximum values have changed in terms of location for that new geometry, and you can gain again the factor of safety for that component. Same for the durability. So here again, the philosophy, to make it simple, is really to simply create your configuration and define a first set of analysis. So here we define static and fatigue. And next, for all the design alternatives, you simply copy and paste your simulation to the configuration you would like to test. So this is really the philosophy of what we call concurrent engineering. This is the first example I wanted to show you. The next example is about assembly simulation. Of course, products are made of fastener to link the components together. So testing the performance of a product is not only to test the resistance of a component himself, but it's really to understand if the connector, if the fastener are properly dimensioned for the product use. So with SolidWorks Simulation, we use what we call the connectors to test those fasteners. And we take into account as well the contact type between the parts. My parts can be glued together, or they can slide between themselves. So this is what we call contact analysis, or in general, assembly analysis. So let's see that example of assembly analysis. So during this demonstration, we will test a sub-assembly of what is the product that you can see on the screen called a Cibotics. Cibotics is a lightweight submersible vehicle. The Cibotics can be remotely operated for use at depths up to 1,500 meters, and its weight is less than 25 pounds. So the analysis for that example will be performed on the support system of the mini grab assembly, as you can see here on that picture. And that mini grab assembly is attached to the Cibotics to grip and hold objects from the seafloor. The mini grab is linked, as you can see, to the sheet metal support part by two clamps and two toolbox fasteners. In SolidWorks Simulation 2014, when you have defined toolbox fastener, they are automatically converted in bolted connector with proper material, position, and strength data. This speeds up significantly, as you can imagine, the simulation setup. And you can see here the bolted connection. The sheet metal support is automatically converted in SolidWorks Simulation into shell for more accurate simulation of thin parts. Steel material now is applied using the default material library on the component of the assembly. And the next step, again, is to define the fixture, the loads on your assembly. So again, fixtures such as fixed or hinge are easily defined directly on the geometry, like the forces. So this means that if I change my design, so in the previous example with configuration, for example, the study definition will be automatically updated. So here we've defined the fixture, we'll define the force on the part as well. Again, simply selecting the faces where I want to apply the load, which is here force, and define the value. We use as well the SolidWorks plan to define the orientation very simply of the force. And we can use as well the geometry. So once we've defined the boundary condition, we need to simulate the behavior of the different components of the assembly to define the contacts. By default, all parts are bonded together, so we'll define surface contact for the parts which are not bonded together. What is great is that SolidWorks Simulation automatically finds the contact set between coincident faces. So I just need to define the contact type for these faces. And once the contact has been defined, SolidWorks Simulation 2014 offers a new tool to visualize the contact type per color code. So what you can see here in red or in purple. This is a great visual tool to make sure you do not forget any part and that the assembly is properly defined. So we just need now to run the static analysis and review the result for performance testing. So you've seen the different steps which are very easy to perform to test your product. So here what we can see, unfortunately, is that the stress distribution shows us that some areas are submitted to stress level higher than the yield point. This is here a risk of performance failure for this assembly. But what you can see as well is the connectors are properly dimensioned with what you can see here, which is called a connector check plot. So on the connector we are fine, but we need to work on the design. And then, how do you communicate with your colleagues? It's sometimes difficult to communicate engineering data. E-drawing is a fantastic tool to communicate your simulation results, to anybody inside or outside of your company. So this is a great tool as well for SolidWorks Simulation. Another test that you can do with SolidWorks Simulation is what we call a drop test analysis. So in many industries, in consumer product, for example, or in electronic, a common way of checking robustness of a design is to perform a drop test. SolidWorks Simulation gives you the ability to drop a design from a specific height or with a certain speed and observe the response over the impact events. Not only does it help in understanding how stress propagates through the structure, but it can as well monitor the acceleration on components, which is a key requirement in the electronic industry, for example. So for this electronic case, the effect of shock-absorbing end protectors can be easily evaluated for the acceleration on these electronic components. So this is what we can get easily with a drop test simulation. The last example of application I would like to share with you is about what's called vibration simulation. So let me run the video as well. So in general, if your product is operating in a vibration environment, or if it can be submitted to dynamic, transient forces, you should know its natural frequency and its dynamic behavior. By understanding the design natural mode of vibration, you can carry out preventive measures such as changes in material, in components, dampers, and so forth, so that your component's material frequency do not match with the frequency of the loading environment. This results in a design that will not only perform as desired, but also have a longer service time. So these are, the few applications I wanted to show you, because these are really the ones that help you testing product performance while you design your product, really during a product development process. So again, the objective is to assess product behavior as soon as possible, so it is still possible to make design changes before manufacturing. So I think, Amy, we have another poll question.
Sorry, guys, I was on mute for a second. So yeah, the next poll question that we have is a multiple choice, so please select all that apply to you. And which of the following types of simulation would you like to perform on your product to test performance? As Delphine has just gone over, the stress analysis, whether that's static or dynamic, fatigue analysis, drop test, frequency analysis, thermal analysis, fluid flow analysis, or others. So we'll give people a few more minutes to respond, or seconds. There's an overwhelming 88% majority are using stress analysis that they'd like to perform to test the performance of their product. A good number of you, 70%, are doing fatigue analysis. There is a good number that are also doing thermal and flow analysis. So Delphine will talk about that a little bit more.
Okay, so we have people interested in different type of analysis. So here really we are kind of focusing that presentation on structural analysis, so fatigue, stress, thermal analysis. But as I mentioned, we can as well with SolidWorks flow simulation do CFD and analysis, and we can couple CFD and FEA, meaning that I can use the CFD result into my structural analysis to make, for example, thermal stress analysis. So we do not have lots of time. I'm sorry, I'm a little bit late. I wanted to cover, I guess, too many things, but I would like to review some of my favorite announcements of the new release. So we just launched SolidWorks version 14, and I would like to share with you some of the announcements I think that boost the user productivity and really the user experience. So the first one is called the Automodal Toolbox Fastener. So let me go. So that's something that you've seen previously, but let me run the video so you can see. Okay. So as I mentioned, when you have in SolidWorks defined toolbox fastener in your model, they can now be converted automatically to ball connector in a simulation study. And during the scanning process, all information related to the location, geometric features, preload, and material is mapped to the corresponding ball connectors. And in addition, the 14 release offers a better visualization of virtual balls. So this announcement, I think, is a great announcement because it will avoid a lot of manual work for our user, speeding up model creation and reduce the potential of errors when re-entering ball properties if you have done them already in SolidWorks 3D CAD. The next one is called the SolidWorks Material Web Portal. So the SolidWorks Material Web Portal is an online material database that can be used for all types of SolidWorks simulation studies. This database is hosted through a partnership with Materiality LLC. So the properties of the material in the database come from published standards, from material, it comes from material vendor data, or through material testing done by the company called DataPoint, which is a sister company of Materiality. So you can search inside that great online database for material based on the type of simulation study you want, or the material model that you want to use. And of course, the material model downloaded from the online SolidWorks material web portal are then added to the SolidWorks simulation material list for your SolidWorks simulation studies. So this online material web portal really provides you a convenient way to find accurate advanced material properties and then test material alternatives. This is another 2014 enhancement that I think really will help our user. The next enhancement I would like to review with you concerns the post-processing area. So the first one is called the mirror result both plane of symmetry. So SolidWorks Simulation 2014, so again the new release, provides to our user the ability to view the result for studies with symmetry on the entire model. So for model that contains planar or cyclic symmetry, you can get the performance benefit of modeling just a portion of the model with symmetry, but now see result for the entire model. So this can assist during design reviews to make results perfectly clear, giving better insight into model behavior. I think this is a great enhancement to facilitate the communication, the sharing of simulation results with people unfamiliar with simulation. We have seen earlier the benefit of using connectors for assembly analysis. In 2014, for Spring, Spotweld, link connectors, you can now readily list the output forces after you run a static or a nonlinear analysis. So now with the new release, users get the output forces for all the connectors we can define in SolidWorks Simulation to dimension them properly inside SolidWorks Simulation. And the last one I would like to share with you among the long list of new enhancements is the capability to compare results across SolidWorks configuration. So I show you that the value of doing concurrent engineering is to test the performance on different design configurations. So now with the compare to results, you can compare up to 4 result plots from simulation studies that are associated with different SolidWorks configurations on the same model. So this cross-configuration comparison mode gives you full control over the display of results by using existing configuration functionality. So I really think that these enhancements offer an easier way to evaluate different design concepts and to be ever more efficient to compare results and pick the best choice. So these are my favorite new feature in SolidWorks Simulation 2014, which I think really boosts the productivity of our user and make product performance testing easier and more efficient than ever.
So we have just 2 more quick polling questions for you guys. The first one is, what is your level of interest in SolidWorks Simulation? Are you just browsing, attending this webinar as part of your general interest? Are you beginning your investigation into virtual simulation? Are you evaluating different products? Or are you ready to purchase? We'll give people a few more seconds to respond to that question, and then we will go into the summary after the next poll question. So answer quickly. And then we will get to a live Q&A. So go ahead and ask your questions in the chat window as well. Okay. And the last question is, would you like any further information from us? Quote pricing information, a product demonstration from a SolidWorks representative or reseller? Would you like to have a salesperson call you or ask questions over the phone? Or nothing at this time? Again, a few more seconds as we go into the live Q&A and summary with Delphine. So one thing I would like to let everyone know is that we will be sending out a recording of this webinar within the next 48 hours or so, so keep your eye out for that, for the replay link. If you are looking for high-quality videos similar to what you saw today, but a higher resolution, you can go to solidworks.com, and in the Resource Center, there's the demo gallery that has a number of great simulation videos that you can look at as well if you want more information. So now for your summary, Delphine.
Thank you, Amy. So this is the end of this presentation. I really hope it has provided you meaningful information about SolidWorks Simulation and its capability to perform product performance testing during your product development cycle. Something important, I think, to remember is that simulation or FEA or CFD not only identify such error early while the impact is low, they can also provide insight to better design and better processes, and then to help you optimize your product. So simulation really provides deeper insight into the quality of your product, into the performance and reliability of your product. So I think that this is the end of that presentation. Again, thanks a lot for your attention, and I will have a look on some of your questions inside the Q&A. We might not be able to answer all of them, but if you want to have more information, more in-depth information, do not hesitate to contact your local SolidWorks reseller.
And just really quickly, some additional resources for everyone. To see what's new in SolidWorks 2014 in all of our products, you can go to solidworks.com/sw-sim-2014, and you can see everything about what's new in 2014. You can also join us for future webinars. We've got a number of upcoming webinars, including a webinar next Tuesday called Model Like a Maniac that talks about some tips and tricks and best practices for SolidWorks part design. So now let's do some Q&A. So there's a question here, Delphine. Is stress and fatigue of plastic parts incorporating creep?
Okay, that's a very good question. So when you do performance testing on plastic parts usually are made of what we call nonlinear materials. So to analyze the stress analysis or the stress result on plastic parts, you will do what we call a nonlinear analysis, and yes, we can include creep when you define your material model. So this is something that you can do. But fatigue is done only on metal parts. There are very few solutions that can handle fatigue on plastic parts, because I think for now the research is not complete, I would say, or not industrial. So when we do fatigue on metal parts, not on plastic parts.
Great. And we do have a couple of questions about what parts of simulation are available in SolidWorks Premium versus a specific flow package or plastic package.
Okay, yeah, that's true. I show in the introduction the entire solution. So I said that we can do FEA with SolidWorks Simulation, CFD with flow, we can do plastic. We have, a very complete solution. So today I really focus my presentation on structural analysis, on SolidWorks Simulation products, okay? In terms of package, inside SolidWorks Premium, what you can do is you can test your product made of linear material or with what we call a linear assumption. So in SolidWorks Premium, you can get the stress, the displacement, the factor of safety. The example that I've used with the bicycle crank, you can do that with SolidWorks Premium. And then you can do as well what's called time-based motion, but I did not do any motion demo here because, again, it was really focused on structural analysis. But then the capability to analyze a drop test, to analyze vibration, to optimize your product is in the the next package, which is called SolidWorks Simulation Professional. And for example, in a new feature that I show for 2014, the translation of toolbox fastener is available in that package, SolidWorks Simulation Professional.
Thanks, Delphine. There's a really quick question. Can SolidWorks Simulation be used to evaluate the deformation of polyurethane?
That would be a nonlinear analysis, yes. Again, when you do performance testing on a product, very often you have either what's called linear or nonlinear materials. So basically, to make it simple, linear material will be materials such as steel, aluminum, and nonlinear material will be materials such as plastic, elastomer, rubber, that kind of material. So yes, we can do that in what we call a nonlinear analysis.
Great. And then there is a question about, do you have to manually input each toolbox fastener, preload, torque, and other fastener info?
So regarding the new functionality of 2014, the toolbox mapping, the goal is really when you have already defined your toolbox fastener in SolidWorks to automatically use them for the bolt connector definitions. You do not need to redo the work twice. But if you have not defined your toolbox fastener in SolidWorks, that's all right. You can define in SolidWorks Simulation the bolted connector with the material data, with the strength, with the preload in SolidWorks Simulation. So going through the mapping from toolbox to connector is not mandatory. It's just a solution when you have done that work already.
Great. I think that is all that we have time for today. Thank you for sticking around a couple extra minutes. I know we did go over your 22 minutes, and we apologize for that. But Delphine was so excited to bring you all this great information about SolidWorks Simulation and what's new in 2014. I hope you'll join us again for future webinars. Thank you very much, everyone.
Thank you.